We took a look at the scene graph in the last episode, and in this episode we are going to take a look on the nodes and the NodePaths. So as I said, Panda uses this scene graph, this concept of a scene graph, which is a tree-like structure to actually render out geometries and this kind of stuff, so everything. And we have the root node, which is the render, and it can have all sorts of child nodes which can be rendered. So first of all, let me show you something. I opened up in the documentation the cheat sheets. I'm going to add this link to the video description so you don't have to search for this. And this is a really nice visual representation how the scene graph, also how the nodes works in Panda. So here is the Panda nodes. We can have light nodes, model nodes, geometry nodes, lens nodes, and so on. And we have NodePaths. So here it says a NodePath is a handle to a Panda node. It's a general way to deal with nodes. So using NodePaths, you can position, you can scale, you can rotate Panda nodes. As I said, I'm going to add this link to the video description. Just read through it because this is a very nice and clear visual explanation. Here are also the global variables or the built-in variables. Here is the scene graph. So we have this tree-like structure, and this is the render, and these are the individual nodes. And I'm going back to PyCharm, and here we have just this simple scene. We have this cube and this monkey head in the same position, and the monkey head is parented to this cube. So if I want to, let's say, print out the type of the cube, it says that it is a type of Panda3D core Notepad. So by default or automatically, the self.loader.load model, when it loads the geometry node from this box, it automatically creates a notepad, so we can reparent this notepad to the renderer. If I want to, so the difference between the node and the notepad is node holds the actual, let's say, the geometry as it says here, a light, a geometry, a model, or a lens node, but you cannot reparent a node to the renderer. You have to convert it to a notepad to actually reparent it to a renderer. So, but if you want to get the actual node, not the notepad, you can do this by, let's say, cube node is equal to cube that node. So call the cube that node method, and you will get back, I'm going to print it out, the cube node. So it says that is a model root box.egg, and if I print out the type of this cube node, we will get back Panda3D core model root. So the model root is just a model node. So if you search for this model root on the internet, Panda3D model root, you will find the documentation for it. Let's open it. And as you can see, although it it is a node, and as here it says, it bases model node, so it inherits from model node. It's a little bit misleading, because some of the nodes have in their names, like in this case model node, but the model root, I would name it like model root node, not just model root, because it is not obvious if it is a node or not. So if you open up this documentation, you will see that this is the model root. We just printed this out. So Panda3D core model root, print type of cube node, and this inherits from the model node, which inherits from the Panda node. So Panda node is a base class for all the nodes in Panda. So if you search for Panda3D Panda node, open up the documentation, and here it says a basic node of a seeing graph or data graph. This is the base class of all specialized node and also serves as generic node with no special properties. You can read through this documentation and you will find all sorts of methods and member variables which are in this Panda node. And one more thing, you can also search for the Panda3D Notepad. Let's open this up. And here it says that the Notepad is the fundamental system for disambiguating instances and also provides a higher level interface for manipulating the scene graph. A notepad is a list of connected nodes from the root of the graph to any sub-node, and each notepad therefore uniquely describes one instance of a node. So you will find this is a very long, large documentation. You will find if you search for this, you will find what you can do with a Panda Notepad. So I cannot explain everything, because as you can see, just the Notepad has a large amount of methods and also member variables. So I'm just going back to PyCharm, and I'm going to do one more simple example how you can do an empty node, then create a box, reparent this box to an empty node, and so I'm just going to show you. So if we want to create something similar to this Blender scene where we have an empty node, and to this empty it is parented, we have parented this cube, so it's now the child of this empty, and we also parented this sphere to this cube, so the sphere is the child of the cube and it is a grandchild of this empty. So if you want to create the same scene, we can just I'm just going to delete this, and I'm just going to create here an empty, and it will be equal to, I'm already imported from Panda3D.core import the notepad. So I'm just going to create an empty notepad, and I'm just going to name it empty. And here when I'm loading the cube model, I'm going to reparent this to the empty, and I'm going to reparent the empty to the, so reparent to the self.render. And now we have two notepads. One is empty, so it's not visible, it's just an empty notepad, and also its child, which is this cube. So we have something like this, an empty notepad, which is parented to the renderer, and we have, in this case this is a Panda, but in our Panda scene we have a cube. So, and we have a cube which is parented to this empty. So it is a grandchild of the renderer. And I can also just load, I don't know, something else. Let's load from my models the monkey, and I'm going to reparent. I'm going to name it monkey also. So monkey, and I'm going to reparent the monkey also to the empty. So now we have both the monkey and also the cube in the same location. And I also can just reparent the monkey to the cube. So now we have something similar to this. Empty, cube, and in this case icosphere, but in a Panda scene this is a monkey. And I just can set separately the transformations or the positions. So let's say I'm going to leave the cube in the default location, which is 0, 0, 0, but I'm going to move the monkey a little bit. So monkey set position, little bit on the X, let's say 2 units, and 0 on the Y and 0 on the Z. So now the monkey is 2 units offset to the right. I'm going to move it even more, so let's say 8 units. Okay, so you should know that the monkey head, as I said in the previous video, is always moved or rotated or scaled relative to its parent. So its parent is the cube. So if I move the cube a little bit, let's say cube that set position, I don't know, 0 on X and 4 on Y, which moves it back, and 0 on the Z. Although we don't see it because this scene is we don't see it because we cannot compare it to our environment or something like that. But now we have this empty. This empty is in the location 0, 0, 0. We loaded this cube. We positioned this cube to 0, 4, 0, so XYZ, and we reparented this cube to the empty. So now this cube moves relative to this empty, and also scales and also rotates relative to this empty. We created or loaded this monkey model. We set its position to 8, 0, 0, so XYZ, and we reparented the monkey to the cube. So now the monkey moves relative to its parent, which is the cube. So, as I said, it's the best to visualize this is inside Blender. So the child always moves relative to its parent. Like in this case, the icosphere always moves relative to the cube, and the cube always moves relative to the empty.